Hey everyone, welcome to homework 14. Today we are looking at comparing real situations and using quadratics to represent those and when those x-intercepts are relevant and when they are not. So first we're looking at two graphs that have quadratic functions, and it asks which object was launched from a higher point. Well, we see that our y-intercept on the blue line, or on G, is higher, so G was launched from a higher point. Which object reached a higher point? Well, the maximum of f is higher than the maximum of g, so f reached a higher point. And then it says which object was launched with the higher upward velocity. So for this one, we're looking at how fast is the height changing. And in this case, f is shooting up a lot faster, and so f would have been launched with a higher upward velocity. And then which object landed last? That is G. G took a longer time to land on the ground. All right, so for this one, it asks us to use this equation to first find the zeros of the function. So remember, we're going to take each one of these and make them equal to 0. We're looking for what value of t would make this 0. So I'm going to say 1 minus t equals 0. Now for this one, I can subtract 1 from both sides, or I can add t to both sides. It doesn't really matter because this will be 1 equals t, right? So t equals 1 is one of the zeros. You could also write this as 1 minus t equals 0 and subtract 1 from both sides. You'll get negative t. That looks like a 4, sorry. You'll get negative t equals negative 1, and then we divide both sides by negative 1 to make this t equals positive 1. But either way, our 0 is t is 1, so 1 comma 0. I think I wrote 0 there, which was confusing. There we go. All right. So that's one of the zeros. The other 0, I'm going to write this in a different color, is 8 plus 16t equals 0. So here, now this is written in the opposite way that we typically look at it. We would normally look at this as mx plus b, so we would normally have 16t plus 8. And you can rewrite it like that, but what you want to recognize is that first this 8 is being added. So that's the first thing I want to get rid of by subtracting 8 on both sides. We'll get 16t equals negative 8. Now some of you are quick to say, oh, that's 2, but be careful, we're dividing both sides by 16. So this is t equals 8 over 16 is 1/2, so negative 1/2, or if you put it in decimal form, that's fine too. You get to negative 0.5, comma 0 is the other one. It says, what do zeros tell us in this situation? So this tells us after, we're talking about seconds, so after 1 second, the ball hits the ground. Now, because at 0 seconds, we know that this was thrown from a given height, negative 0.5 is not meaningful. So for this second question, no, negative 0.5 is not, because that's the time potentially before it was thrown, but that time wouldn't be represented by this equation. From what height is the ball thrown? Explain your reasoning. So here now we need to look for the y-intercept. And so we can do this by doing our FOIL method and finding out what is the constant. Notice this is written a little bit differently, but 1 times 8 is still 8. And then if we do 1 times 16, we'll have plus 16t. And then negative t times 8 is minus 8t. And then negative t times negative 16 is going to be negative 16t squared. All right, now again, you can recognize this is a gravity function, right? We see that negative 16t squared. But here, our constant is 8, right? So 8, and in this case, it says feet. About when does the ball reach its highest point? And about how high does the ball go? Show or explain your reasoning. Well, we know our x-intercepts are negative 0.5 and 1, so we can add those and divide by 2 to find the x-intercept of the vertex, which would show us when the highest point is. So if you do that, you will get 0.5 divided by 2, which is 0.25. So at 1/4 of a second, it's at the highest point. And it says about how high does the ball go. So you're going to plug in 1/4 or 0.25 into the equation to find that out, right? So you would put 1 minus 0.25 times 8 plus 16 times 0.25 squared. and see what you get there. So find the answer to that, and that will give you the overall highest point at 0.25 seconds. And so again, I'm using my x-intercepts because on the graph, right, 0.5, negative 0.5, and then 1, it would be between that, right, at about 0.25 that we would have that vertex. And in this case, it's the highest point because it's a gravity function. All right. Number 3, the height in feet of a thrown football is modeled by this equation, and time is measured in seconds. What does the constant 6? So this is the starting height. It's a pretty tall football player, or he's throwing above his head. Starting height. What does the 30t mean in this situation? And this is upward velocity. So this is how fast the football player can throw the ball, right? So again, we talked today about real world situations and when this math would come into play, right? With a lot of sports players, they look at the speed of how fast they can throw something. How do you think the squared term negative 16t affects the value of the function? So negative 16t means it's going to bring this down. It brings it down. And this is showing the effect gravity has. All right, number 4. The height in feet of an arrow is modeled by this equation, where t is t seconds after the arrow is shot. When does the arrow hit the ground? So again, we're going to look at our our x-intercepts to find that out. So we'll say 1 plus 2t equals 0, and 18 minus 8t equals 0. And so I now want to solve for t, so I'm going to subtract 1 from both sides. 2t equals negative 1. Divide both sides by 2, we'll get t equals negative 1/2. So likely this is not going to be relevant in this situation. Subtract 18 from both sides, we get negative 8t equals negative 18. Divide by negative 8, we'll get a positive answer here. Go ahead and calculate that decimal to give you that exact time that then the arrow will hit the ground. From what height is the arrow shot? Show or explain your reasoning. So again, we have this positive 18 and this positive 1 here, and when we multiply those, we'll get 18, and that will be our constant. So that is 18. Again, we're modeling this, yes, by feet, so 18 feet. And we know because 1 plus 2t times 18 minus 8t, we can show that equation to be 18, and then we would multiply minus 8t, multiply the inside plus 36t, and then the last terms would be minus 16t squared, which is our gravity. All right, let's take a look at the next one. All right, so here we have 2 objects that are launched into the air. The height in feet of the first object is in this equation, and then the height of the second object is here in this equation. In both functions, these 2 equations, t is seconds after launch. So we're looking at time in seconds. Which object was launched from a greater height? Explain how you know. So f of t was launched from a greater height, and I know because the y-intercept is 4. The constant is 4, so the y-intercept is 4. And the other one is 2.5. And 4 is greater than 2.5. Which object was launched with a greater upward velocity? So here now I'm looking at the linear term, and so that would be g of t, because the linear term is 40, and 40 is greater than 32. Number 6, predict the x and y intercepts of the graph of a quadratic function defined by this expression, and explain how you made your predictions. So we would say x equals negative 6 and x equals 6, because negative 6 plus 6 equals 0, and 6 minus 6 equals 0. So then it says check your predictions by graphing the equation. Well, let's go ahead and do that. All right, so we have x minus 6 times x plus 6, and we're going to graph. So now, if your graph looks like this, and a lot of you have been asking me, my graph, I can't see anything, right? Go to Zoom and start by pressing 6 standard. That'll give you an idea of what we're looking at. So here we can see that -6, and it looks like that +6 as well. And now we want to see what the y-intercept is too. And if we predict that, if we know it's -6 and +6, we can predict that -36 would be the y-intercept. So let's go ahead and go to the window, and let's change the x min to -7 and the x max to 7. So we're looking closer to 6 and -6. And then let's change our y min to -40 because we're looking towards the bottom there, okay? And press graph. Now we can see a lot more clearly. 1, 2, 3, 4, 5, 6. That looks like a pretty perfect 6 and a pretty perfect -6 here. And then down at the bottom we're looking, and we can press trace. And notice that here, when I press trace, x equals 0 and y equals -36, I don't need to do any calculation of the minimum here because I can just see this by tracing. Now, if you press trace and you couldn't quite get it to where x equals 0, it was looking like this or something, then you could do that second calculate and calculate the minimum, but we can see this here just by tracing it. So we can confirm that that is real, all right, or that that is true, rather. So we can say, because I also didn't write the y-intercept here, but we can say y-intercept is 0, -36. All right, and so check. Just note that you did it. You can draw a little graph here where it's crossing 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So -6 and +6, and then -36. 0, -36 down here on the y-axis. All right, number 7. A student needs a loan to get $12,000 for the first year of college. So all the students are starting with $12,000. There's Bank A, Bank B, and Bank C, and they all have different interest rates. It says if we graph the amount owed for each loan as a function of years without payment, predict what the 3 graphs would look like. So let's do that. If we're starting at $12,000, we're going to start somewhere on the y-axis. They're all starting at that amount. So Bank A has 5.75, Bank B has 7.81, so that one's growing the fastest, right? So we'll mark Bank B going up the fastest, and then these are exponential, so they should have curved lines. Bank A would then be the next greatest one, and then Bank C is going to be the slowest growing one with 4.45%. All right, so now I'm going to want to write an equation for each of these situations. So A would be 12,000 times. Now, our factor here for A is going to be increasing, right? That we're increasing. So we're going to add 1. Remember, if it's increasing, we're adding 1 to the percent, and then writing the percent as a decimal. So 5.75% is 0.0575 in decimal form. And then this is exponential, so time goes in the exponent. That's A. Then we're going to do B. So again, they're all starting with 12,000 times 1.0781 to the power of x. And then C, the last one, will be 12,000 times 1.0445 to the power of x. Don't forget that, to the power of x. So now we need to take those and put those in our calculator. So I'm going to go back to my y equal. Let's clear out what I had before. Let me just shift back so I don't forget. 12,000 times 12,000 times 1.0575 is the first one. And then we're going to go to the power of x. And then I'm going to go to the next one, 12,000 times 1.0781 to the power of x. And then the next one, 12,000, C is 1.0445 to the power of x. All right, so when I graph these, now notice again, I cannot see my graph, and we're starting at 12,000. So let's change my window. I'm not worried about anything in the negative value, so I'm going to put it at 0. And then my x max, looking at this question, it's talking about 4 years and 10 years. So I'm going to make it 10. Actually, let's make it 11, so just a little bit beyond that. And then y min, I don't need to think about negative numbers, so I'm going to start at 0. And the y max, I'm starting at 12,000. It's going to go above that. So let's put it at 30,000 for now and see what we get. Okay, so now I can see all three of my graphs. So that actually worked out pretty nicely. And so now what I'm going to do is I'm going to go to second table, and I'm going to look at what it looks like for each one for the years. So after the 4th year, it looks like the second one is already greatest at 16,211. So it says, based on your graph, how much would the student owe for each loan when they graduate from college in 4 years? So A would owe $15,007. Looks like, B would be 16,211, and C would be 14,283. So the loan that we would most want would be C, because we're going to owe the least. And that's based on your graph. If no payments are made, how much would the student owe for each loan after 10 years? So again, you're going to go in and you're going to look at what is it at the 10-year mark, right? How much does each loan, how much will it owe after 10 years? So you can go ahead and fill in for A, B, and C what those loans would be after 10 years using that table in your calculator. That's on you to do. All right, number 8, it says the functions are given by these equations. So here we have a linear, and here we have an exponential. And again, I know because my x is the exponent. It says which eventually grows faster, f or g. So g, because it is exponential. We know that exponential functions will always outgrow eventually other types of functions. It uses graphing technology to decide where the graphs of f and g meet. So we're going to go back to our calculator and let me clear out all these and go back up. All right, we're going to put our equations in. So 13x, I always forget that that's 13x plus 6. That's the first one, and then 0.1 to 1.4 to the power of x graph. Okay, now here I'm going to go back to my Zoom 6 standard to see what happens, and now I can see this a little bit better, and I can see where they intersect here right close to the middle there. So I'm going to press zoom in press enter to zoom us in, and then again I'm going to do zoom one more time. Let's get a little bit closer. Okay, now I'm going to do second calc, and I'm looking for that intersect, so number 5. And it says first curve. So let's see, where's my cursor? I'm going to put it here. Say enter, enter, guess. There we go. All right, so our intersection here looks to be at about negative 0.45, and where y equals 0.08. So it says use graphing technology to decide where that meets. So I'm going to go ahead and mark that as negative 0.45, comma, 0.085. Yeah, so we can make it 6, round up. Okay. All right. All right, our next few problems are part practice. So this first one is talking about the road. And so this is the side of the road shoulder. That's the side of the road. This is the other side of the road, what's called the road shoulder. And then the ground actually has a curve to it. So the ground that we drive on is not perfectly flat because it allows the rain to come off the road and go into the shoulder and not be on the road itself. So if you didn't know this, roadways are also, they're called crowned, which means they have a little bit of a hump to them so that the water falls off of them and doesn't stay on the road. This is, roads that are constructed well, right? So sometimes if there's potholes or stuff, that's not true. But in this case, this is the example. So the width of the roadway is 18 feet. So this is 18 feet. A function f that models the curved road surface is this function here. Which of these statements are true? So the y-coordinate of the crown occurs at x equals 9. So it's asking if here does x equal 9, right, at that vertex. Well, if we know the road is 18 feet, that means this is 0, right? And this is 18 comma 0. The middle point between 0 and 18 would be 0 plus 18 divided by 2, which is 9. So at x equals 9, that's where this crown would be. So that does, in fact, ring true. It says B, the crown is 9 feet above the ground. No, not necessarily. So actually, if we were to plug 9 feet into this equation, right, to find the height of this, we would not find that it is 9. So that is not true. 9 is the feet across to the middle of the ground, not the height of the ground. So this is not true. Letter C, the y-coordinate of the crown is approximately 0.4. So to find that out, that would be how high it is. We're actually going to plug it in, right? So we'll do negative 0.005 times 9 times 9 minus 18. We're replacing that x value with the x value of 9 because we know that that's what it is. So then we would get, if we go ahead and plug that in, calculate that in your calculator. Let's give a second quit. And I'm going to put in negative 0.005 times 9 times 9 minus 18 is negative 9. You can calculate that. Then we will get 0.405. So this equals, so that is true. It is approximately 0.4, so that works. The x-intercepts are 0 and 18. That is also true. We would see this would be 0, this would be 18, because it's 18 feet across. And the x-coordinate of the crown is the average of the x-intercepts of f. So that is true, because we saw that here. That's how we find the x-coordinate of the crown or of the maximum. They're just using a different word here for maximum, so this is also true. All right, for this next one, we have the graph of the function, and this one is asking you where it is increasing. So where are the y values increasing? Well, although this arrow was pointing up, from left to right, this is actually decreasing until we get to this point right here. And then it is increasing after that. So that point right there is between 0 and 1. So I would say that that is at 0.5. Now at that point, it's at the very bottom. So it's not increasing at that point. So we are going to leave that as an open circle. And then we are going to draw our arrow to the right because after 0.5 is when our graph is increasing. So in your technology, you would choose this arrow right here and you would put that on the graph at 0.5. And then it says, represent the set of values for which f of x or y is positive. So it's positive starting at our x-intercepts after that. So on the one side, it's when it's greater than 4, right? When we go this way, it's greater than 4. It's going to stay positive. And so we would have open circle at 4, it's 0. So we're going to keep an open circle and then to the right. And then the other side is going negative, right? It's going this way, and that's after negative 3. So I'll have open circle on negative 3 and then our arrow pointing this way. And so again, using your arrows here, you would select this one and this one. And these are open circles because on that point, it's not positive. On that point, it is equal to 0. So 0 is neither positive nor negative. All right, our final part is about this projectile. And so something is being shot up in the air and then coming back down. Which of these statements is true? So for this part, I need to make sure that you are listening. So I'm not going to circle it on the paper. I'm going to ask that you listen to which one I'm selecting. So the projectile reaches a maximum altitude of 12 feet. So we see that 12 here, but that is measuring, that 12 is in the x value, so that's measuring the time, versus this y value is measuring the feet. So A is not true. B, the projectile reaches a maximum altitude after 12 seconds of flight. Yes, that is true. After 12 seconds, we are at the maximum, so B looks good, but remember I told you we have to read C and D too. C says the projectile is launched from the ground. Well, we see that our y-intercept is 0, negative 5, so it can't be launched from the ground. It's launched from 5 feet. And then D, the altitude of the projectile, so the height of the projectile, that's what altitude means, is increasing on the interval between 5 and 20. So between 5 and 20, it does increase, but then it also comes back down and it decreases, right? It goes up and then it goes back down. So that is not true. So we were correct that B is the best answer. For part B then, it says the table models the projectile from part A. So this is the table of those points. Which of these statements is true? Is h of 4 less than h of 20? Well, no, they're actually the same. So that's not true. The flight is symmetric about the line t equals 10. So notice that here around 12, we have things being even, and it is symmetric here where x equals 12, not 10. So that is also not true. C, the projectile will hit the ground at some value of t less than 24. Well, it looks like at 24, it is still in the air. So that is also not true. That leaves us with D. So let's look at D. D is saying if if A is greater than 0 and less than 12, then when we input something for A, they are equal. What this is saying is that each side of the graph is symmetrical. So if, for example, I were to plug in 8 for A, I would get h of 12 minus 8 is 4 equals h of 12 plus 8 is 20. We see that in our table, h of 4 is 13 and h of 20 is also 13. So these values are actually equal if we were to plug in a number between 0 and 12 for A, that those two outputs are the same, right? You can see that if we were to do, let's do another example. Let's say I were to do 4, right? So if I do 12 minus 4, h of 8 equals h of 4 plus 12 is 16. All right, if I plug 4 in here for these, h of 8 is 17.8 and h of 16 is 17.8. These are in fact equal to each other. So D is our best answer. All right, let's go back up real quick to the last part of the classwork, which was this part here. So this is player A on the graph, and player B is defined by this equation. It says which player's baseball stayed in flight longer? Well, here the x-intercept and the place it lands is a little bit after 5. Here my x-intercepts would be 4, 0 for 1. The other one would be negative 1 over 16, right? That's a negative number, so that's unlikely the one we would be looking at is this one here, which means that player A stayed in the air longer because it happened around 5, and the other one happened at 4. Which player's baseball reaches a greater maximum? So to do this, we need to find out what the maximum of this equation is. Here it's a little over 100, so let's look at this one here. If we want to figure that out, we need to figure out what is the x value for the maximum. And so we're looking at the difference of negative 1/16 plus 4 divided by 2. Right? 1/16 is actually pretty close to 0, especially that negative 1/16. But if you want to go ahead and do this, you would do 1 divided by 16 is 0.0625 plus 4, and this is negative, is 3.93 divided by 2 is going to give us about 1.96. All right, and so that then, if I plug that in, that's very close to 2. So I'm going to estimate that this is close to 2. And if I plug 2 into my equation, I'll find out then what the height is at the maximum, right? So let's take a look at that. If I plug 2 in here, I get negative 16 times 2 minus 1, and then 2 minus 4. This is going to give me negative 32 minus 1 is negative 33 times 2 minus 4 is negative 2. So that will be positive 66. So here it's at 2, 66 approximately is the maximum. And so A is actually a greater maximum height than B, which is going to be about 66 feet. And it says, how can you find the height at which each baseball was hit? So A, we look at y-intercept, or the vertical intercept, which is here. It's going to be somewhere under 10. And then B, we look at constant in the standard form of the equation. So if we multiply -1 times -4, we would get +4. And so that would be the constant there. Okay, so your code word for today is lotus. Code word for today is lotus, type of flower. Put that somewhere on your paper. And if you have any questions, reach out. Happy homeworking and see you tomorrow.